Hello ladies and gentlemen. Today we're going to be looking at a way to use Excel to plot trend lines of best fits from which to interpolate values. I was sent some dummy data right here, and it's a mean OD value and a concentration in milliliters. Now, first of all, what we need to do is decide on when we're going to plot our graph, what is going to be our X and Y axes. X is the horizontal and Y is the vertical. In order to figure this out in Excel, we need to remember that when we're plotting graphs, X is going to be first. So let's move Y to the right. There you go. And now we're going to be plotting these values. So let me just select the data in question. And insert a scatter graph. Now you might be wondering why we're using this with dots, and that's the best way that I found to create a trend line. If we have lines already there, it makes things a bit complicated to see. Now let's have a look at how we can add a trend line to this. What I normally do is you can go on the plus button right here and go for trend line, but this is not always there, unfortunately. Another way to get to it is by double clicking on some of the points themselves, and you see that this little plane appears. If you were to then right click on the dots themselves, you can go on add trend line. So this is the same thing as this right there. You see that it was ticked. Now that we've done this, let's have a look at the options. And the options include adding several types of trend lines. And you have linear, which is the simplest one you can get. You have logarithmic and polynomial. Now for this kind of data, when we have concentration and mean OD value, I would advise a polynomial of order 2. You might want to have more orders to your polynomial. However, I may not advise this because then you fall into the issue of overfitting. You see how there's a kink in that line. Maybe that's not meant to be there. I would go for order 2. However, you might want to go for logarithmic. If you were to go for logarithmic data here, a logarithmic trend line, you'll have an issue. And this is it. The trouble is that there is no logarithmic 0. So if you have a 0 negative value here, it's not going to be able to fit a trend line. So what you can do to rearrange this is get rid of the 0, quite simply, especially if it is just a data set with only positive numbers. So here, if I get rid of the 0 by dragging this little square that I found in my data set, by the way, these colors that came up appeared when I clicked on my graph. And I saw that little square, so I dragged it to the bottom to get rid of the 0. Now the 0 is not part of my graph anymore, and I can actually go ahead and let's double click on the spots themselves, add a trend line, and now we should be able to add a logarithmic scale. Now, for this example, I'm going to use a polynomial of order 2. And what we're going to be doing now is we're going to be showing the equation from which to then interpolate data. So unfortunately, I've been clicking a few too many times, so there's 2 lines that appeared right here. If there are too many, you can simply just click on one of the lines themselves. I might have to zoom in to click on the line itself. There you go. And then I can delete it by just clicking on delete. Now I've got too many and I forgot which one is which, so let me just do all of that again. Exponential, more options. Let's go for polynomial, order 2. In order to interpolate data, I wanted to see the equation. So I'm going to tick this box right here, display equation on chart, and I also want to see the r squared. Now, there's no need for this right here, but it's always useful to see. I always like to put that right there. Let me make it a bit bigger because it's a bit small. Don't know if you can read it. It's quite important. Alright, so remember that we've chosen our y and our x depending on where we wanted it on the graph. But it's still difficult to see what is what on this graph, and I would always advise as a result to add axes titles. Let's have a look. Should we have anything else? A legend wouldn't make much sense because we only have one type of data here, so let's leave that empty and let's add a legend. So let me move that here. What do we have here? This is our y. What is our y? Our y is mean OD value, and our x is concentration. happens to be in microgram per milliliter. All right, should always have the values, sorry, the unit that goes with the values as well. So this is our concentration. Now that we know what our axis is and we have our trend line and we have an equation for it, what we can start doing is try to interpolate. So let's say I wanted to know what would be my value of y for a specific value of x. So x is my concentration, y is my mean OD value. All right. Here we had a specific data frame. Let me just name them so that I can refer to them. This is going to be my data frame 1. And I'm going to have data frame 2 here. Now, what we have here is an equation for y. Y is our model for this line, the trend line. What we have here is an intercept. The intercept is the value of that equation that does not have an x next to it. So this is the last value here. Let me write that down here. So intercept. Then we're going to have the first coefficient, which is the coefficient next to an x that is not to the power of anything. So if an x is not to the power of anything, it's like it's to the power of 1. We call this a coefficient. Polynomial 1. I think it's polynomial 1. Technically, it's polynomial of order 1, but there's already enough written here. Let's not add more to it. Let me delete this because there's no need for it. So this was our coefficient of x to the power of 1, polynomial 1. Let's do coefficient polynomial 2. Again, there's too much written here. So that's 1 and 2. So our intercept here is 0.0244. Let's use that. Our first polynomial of x, which is the x to the power of 1, so that's x on its own, is 0.0497. And lastly, our second polynomial of x coefficient, which is x squared, the coefficient is that value here, is a negative number, so it's minus 0.0009. Those are our values here in our model for the trend line of here. Now, what we have as a result is we have a modeled y. So this is the y value we have here that is modeled by the line. Let's say that I'm looking for a value of y depending on x. So here I choose my x value. Let's say I choose let's say I choose a value of x that will show up on here. So let's say I go for let's go for 7. Why not? Just randomly. So let's say my value of x is 7. Now I know that my modeled y is going to be my intercept, which is that value here, plus the x that I've already got here multiplied by the first coefficient, which is that one. And I'm going to add to this, and I'm going to add brackets just to make sure that I'm not making any mistakes. My x value to the power of 2. So that's x to the power of 2. And I'm going to yet again add more brackets to make sure that I'm not making mistakes. It's x to the power of 2, and I'm multiplying it by that last coefficient, so coefficient for polynomial 2. There it was. So I'm going to multiply it by that value. So my modeled y here for chosen x value 7 is 0.32. Let's have a look. If it was a value of 7, which is between 5 and 10, so around there, I'd have 0.32, which seems about right. If we look at that line, it seems to be 0.32. All right. Now, this is the first chosen x value that I've got. But let's say I've got more than one. Let's say I want it 3 times. So I've got 7 here. Let's choose something in between the 2 here. Let's go for 12. And then let's go for 17. Why not? So now I want to do the same here, and I can drag this, because what's going to happen is that it's going to apply the same formula to the cells above. Let's call this data frame df2. All right. So now I've got my second data frame with my modeled y values from my chosen x values. What if, on the other hand, I want to do this, but switch them around? So I want to choose my y value and get my modeled x value. In this case, what's going to happen is I'm going to be looking here on the y-axis, choose a random value. Let's say I go for 0.5, and then I want to know what the x here would be for that y value. What we can do is something very similar. So let's copy all of this. Let's paste it here. I had df2, so now let's make it df3. The intercept coefficients are going to be staying the same, but this time I'm going to have my modeled x and my y value chosen. So I'm going to choose a y value, and an x is going to come out. In order to do this, we unfortunately have to use an add-in called solve. In order to get the add-in, you can go on File, then Options, Add-ins, and you should find it here. It should maybe be in this list instead of the one above. It's in the one above on my PC because I've already got it. So you can just go on Solver, Add-in, press OK. You might have to restart Excel, and then you'll have that add-in in, I believe it's in Data. There you go, in that little tile. So if you have to go on Solver, what I'm going to be doing now is I'm going to try and set a specific value by changing another value. So I'm going to be I'm going to be setting that value of y, which we've chosen to be 0.5, just for a check. So our value of y here we've said would be 0.5, and I want to know how my x value changes with that set value of 0.5. So this is my formula for y. So my objective for that cell is going to be value 0.5, we said, and I'm going to change x, my modeled x, accordingly. So let's solve for this. There you go. It's solved for that model and it's given us something like 12.3. Okay. Now we can do the same for all the others. So let's solve. Let's have a look which one it shows. I think that's the right one. No, it's not. So you see, you have to be careful that you're picking the right cells. So I'm setting an objective for y. I want it to be a value of, so that was 0.5. Now let's go for 0.6. Why not? Let's go for 0.6. And we're going to be changing a different x. Let's go for that one right here. Solve. There you go. You found a value for x. And we can do the same thing yet again. Solve for that value, setting it to, instead of 6, let's go for 3, not 4.3. And we're going to be changing our x value. Solve. Oh yes, you see it put it in twice. You always have to be quite careful. There you go. Solve. It's done it for us, and it's found these values for us. I don't like to have 0.5 and 0.6 here since they're larger, so let me move it around. There you go. So now I've got my data frame 3, where I've got my modeled x for y chosen values. If I do this, then let's say that I would like to have these values on my graph so that I can see everything in one place. Now that's possible. What I can do is I can click on my graph, right click, and I might have to go, there you go, select data. And now I can add data. The name of the series might be, let's say, modeled X, because we're choosing the X that we've got. The X values are going to be these values here, and the Y values are going to be these values here. Okay. You can see you've got your spots on the trend line that we've got right there. I like to have the actual values of chart title is always good, data label. There you go. Now it can get a bit crowded, so I would advise having the whole thing a bit larger. I always put this on the side, and maybe you want to move certain values around because it's a bit too crowded. There you go. We also have several colors here, so you might want to have a legend in order to know which one's which. All right. I hope this was useful. What we've done here is that we've interpolated certain values according to a trend line that we fitted from data that we've got from our own experiments. I hope this was useful. You might want to have a chart title and things as such, and you can change that for yourself. I decided to add the challenge of trying to do all this with logarithmic scales. So let's move all this over there. Oh yes, it doesn't like it when the cells are together. So let's do that instead. So that was our DF3 with squared values. This whole thing has got it squared. So now let's change this. Let's double click on the trend line and change this to logarithmic. Now remember there's no zeros there, so hopefully there you go, it will work fine. Now see how the orange dots are not in the right place anymore. If that's the case, then let's remove them because otherwise it's quite confusing. Right click, select data, and the modeled X, we don't want that anymore. So actually I'd like to remove it because it's not very clear as to if it's modeled with a quadratic function, which is the one that we had before, polynomial 2, or a logarithmic, which is a new one we're going to make. So let's remove that, press OK, and now they're gone. Okay, beautiful. So now that we've got our logarithmic equation here, what we can do is the exact same thing as we had before. So let's call this, that was DF3, let's now make DF4. Now that we've got DF4, we still have an intercept. So that's our intercept is, let's remove all that because it's a bit confusing. What was our DF4 intercept? Our intercept is the value that has no x, and we can see that it's minus 0.1, what was that? Minus 0.1345. That's our intercept. Now, our next coefficient is not of a polynomial because our x is not to the power of anything. So it's actually a coefficient of log x. Let's call it like this. This is just a name that I'm giving it. You can call it something else if you want. Let's delete this because there's only one x, so there's no other coefficient. The coefficient for this log x is 0.263. Now, the modeled x that I have here is going to be like that. So we're going to be using solver again, which means I'm going to have to choose a y value. So let's choose the y value 0.5, let's say 52, just so that it's a bit further away from that value here, 0.42. Let's do that. All right, so I want my y chosen value to be 0.52, and I want to know what my x will be as a result. In order to figure this out, this 0.52, I have to write an equation for y for the variables that I've got above. And how do we do this? Well, we've got our intercept, and to which we're adding this first coefficient multiplied by x. It's not just x though, it's going to be the log of x. So we need to do, there we go. This is the natural log, and this is the one we want in this instance. However, I'm afraid I'm going to have an error because there's nothing in this cell. I should have actually written something in that cell, just a dummy number. So if I press OK, there you go, it just gives me an error. So let's put a dummy number. Let's put, what did we have before? We had 7. There we go, and it is giving me a y value. In order to figure out what my modeled x is for a chosen y value, which if you remember was 0.52, I can go on solver again. So that's going to go on data, solver. I'm going to be setting my y value to be 0.52 by changing the cell for my modeled x, which is right there. So that's I18, solve. And there you go, it's giving me an x value of 308. That's this is a perfect time to show you that you really need to check the values that come out against your data. If you have a look at 308, that really does not seem right when you look at the modeled trend line. 308 would be way to the right here on the x-axis, and it would not be 0.52. What this means is that I might have made a mistake in my equation itself. You see how it says a log here? Log is actually normally to the base 10. And so what you want is the natural log, which is ln. If you do this, let's have a look at our result once we solve. Everything should be the same. The error we encountered here is because the machine was trying to interpolate the modeled x with a random starting point, and the starting point was way off, and therefore it didn't do very well. One of the things I would advise then is to choose a modeled x, just having a quick look at your graph. So here we were choosing a y value of 5.2, and sorry, a y value here of 5.2. And if I have a look here, 5.2 is about there. If I drag my mouse to the right up to that trend line and then go down, I can see that it's between 10 and 15. So let me put a y value, an x value of, let's say 12. And what's going to happen now is that the machine is now going to try and solve based on that value. So if I click on here, you can already tell that when I write 12, I'm quite close to the 0.52. Let's click on solver and do everything again. So here I've got I19, which is the correct cell, I18, which is again the x value, that's the correct cell. Press solve, and now it actually comes to a conclusion. So we've got our 0.52 for a modeled x of 12. We can continue doing something similar with other values. Let's try that. So I tried 0.52. Let's try, let's go for 0.35. So here I'm going to try this again, solver, for setting this to 0.35 by changing the variable cell, which is our x, which is this one right here. Solve, and it's found something. So I've got 6. Let's stick to what we've got here and add these values to our graph. So if I was to right-click in the graph, select data, add data, what's going to be the name of our series? Let's go model x again. Our x's values are going to be these two, and our y values are going to be these two. Okay, and there you go. Now you have your y values for your logarithmic model right there. And you can see here it says log y. So this is a neat way to remember which is which. You can also add title if you want. All right, I hope this was useful. Do let me know in the comments if you've got any more questions of things you could do going forward from there. All right, have a nice day.